So, Mr. SooHoo.
So, Mr. SooHoo.
Unit 8 video coming up.
Okay, so in this problem we're going to use a sum formula for finding the sum of positive integers less than 200. So basically n stands for the number of integers that are positive less than 200. So we've got 2, 4, 6, 8, 10, it keeps going on and on. And then 198 is going to be the last positive integer. So we found out that there's 99 terms within there. And then so we're going to find the sum of all the integers. So basically we plugged it in 99 to n. And the first term is 2 plus the last term, which is 198. It's over 2. And we just divided and multiplied it out. And so the 99th term is going to be 9,900.
Boom.
So this is the answer for number 1, the previous problem. And to put in summation notation, we're going to write it out like this. And for this one, I is going to equal to 0. And it's going to be 2i plus 2. So we're going to plug in 0 to our equation. And we're going to follow it up with 1, and then 2, and then so on and so forth. And once we get that, we come down and simplify it out here. And once you, hold on, don't pause it. Ronnie Appleton. Alright, and then once we do that, we simplify it to, it's going to be 2 plus 4 plus 6, and then it's going to be plus 8 all the way to 198. And that is E in summation notation.
Alright, so we have geometric sequence, geometric series, arithmetic sequence, and arithmetic series. So for the first one, we have geometric sequence. And sequence means to separate the numbers by commas, so that's what we did here. And the pattern is we multiplied by 2 right here, and the formula is an equals a1 plus n minus 1 times d. Geometric series right here. Series means to separate the numbers by plus signs, and so that's what we did here. And we still multiply each numbers by 2, and the formula is an equals a1 r to the power n minus 1. Arithmetic sequence. So arithmetic means to add. So, and sequence is still separating the numbers by commas. So arithmetic, it means that we have to add the numbers. So that's what we did. Plus 4, and the formula is Sn equals n a1 plus an divided by 2. Arithmetic series. Arithmetic, we added numbers plus the pattern by 2. Series, we got the plus signs right here, and the formula is Sn equals a1 1 minus r to the power of n over 1 minus r.
Okay, so at Vaughn's grocery store, you stock peaches into a square pyramid.
Did you?
Once done, you notice that the pattern of the top 3 layers has 1 peach, then 4 peaches, then 9 peaches. This pattern continues for 15 layers. So basically, we're going to write a summation notation to calculate the total number of stacked peaches. So first there's 1 peach and 4, then 9, so we write 1, 4, and 9. And then, so 15 layers, so we're trying to find the 15th term. So we notice that if you square each one, like 1 and then 2, it comes up to 1, then 4, then if you square 3, it comes up to 9. So if I equals 1 in the summation notation, we already figured that out. So then we're trying to get the 15th term. So that's our summation notation. We all plug it in. Comes out to 1 squared plus 2 squared plus 3 squared, and all the way to 15 squared. So all those numbers in between 3 and 15, we also squared those. Write them out. Once we add them all together, we get our total number of peaches, which is 1,240.
Oh, it's going? Is it really? Oh, okay. So, at the age 19, you make a one-time deposit of $6,000 in a retirement account that pays 7% interest per year. On your 40th birthday, how much will you have? So, we want to take our 40th birthday, and since we started at 19, we're going to subtract it at 19 because we didn't start at 0, we started at age 19, and that gets us to 21. We're going to use our formula a1 equals to r to the power n minus 1. When we plug that in, we get 6,000, and it's 7% interest. When you plug it in like multiplication form, it's 1.07, so keep that in mind. So we put that there, and we put 21 for n minus 1. And we get $23,218.11 for that one. The next one is what about our 65th birthday? So we're gonna do the same thing, but we're gonna put a to the 65th equals 6,000, 1.07, and we're gonna put 46 minus 1. And that gets us to $126,014.71. And then the last one was, what would you get per year? So we basically keep the same equation. We just take AN, since AN is last year, we take minus 1. No, since AN is this year, we take minus 1 to make it last year. And we multiply that by 1.07 because that's a 7% interest we have.